Have you ever wanted to port your own 2J cylinder head? Well, this is the series for you guys. All right, guys, this is a porting series that we're going to do. Basically, tips and tricks, how to port a 2J cylinder head. This is a GE, so we have the smaller but higher raised port in the GE. In the Einstein app, we're actually going to go through measurements and stuff like that. So it's going to be a more in-depth series of this series. But for this one, we're just going through basic techniques. How to use the burr, what burrs, what tools. Again, these have a bigger, straighter shot exhaust on them over the GE GTE because they're narrowed in, so they have a straight port and two ports that lean in. So they are harder to port. These are the easier head to port. Like all these, they have a lot of core shift. So what I'm going to teach you in this series is how to compensate for the core shift without making the bowls and the throat and everything too big. So something that's really, really, really responsive. So circuit, everything like that. So this is really a very, very basic porting series on something that you want to make 500 to 700 horsepower, a circuit, something that's quick. I found these in circuit cars seem to be a little bit better. Again, they are a little bit big on the exhaust for my likings and a little bit small on the intakes. But again, we want airspeed with this thing. We want power out of the corners. So yeah, we're going to cover a few basics. So I think what we're going to start with in this series is what you need. So we're going to keep it really, really simple. A little bit of lube, a torch, 2 burrs. So we're using a 5/8, and I think this is a 3/8, both eggs or whatever they're called. These are killer carbide burrs. Again, I like a quality burr, but you can pretty much use what you like. Just don't go anything that's too aggressive. So I'll come back to this in a minute and we'll talk about burrs just in general, so you have an understanding of what to actually buy and what you're actually looking at when you purchase a burr and how that burr is going to feel. Because I can look at a burr now and I can tell you what it's going to do to me as far as what it's going to do to my hands, how aggressive it's going to be on the job. So that's the burrs. A set of calipers. You can go digital, or if you don't want digital, my old favorites, just normal set of calipers, stop, go, stop, go. So we can set them for our throats. So we know that, there we go, we know we can go through each one when we make the throat bigger. And again, we can compensate for the core shift this way. So, and this is where CNC is let down ever so slightly, and why I seem to see better gains with hand ported over CNC to a certain RPM point. Obviously, if we were turning this thing at 10,000 RPM, we need the port so big that even if we overcut with a CNC, it's still going to be on size. But when it comes to our street and our circuit type cylinder heads, size is everything. Because again, when we talked about an induction series, airspeed is what fills the cylinder. And airspeed is what controls our restriction in our engine. If we don't have airspeed, we actually have restriction. And we've had this debate where people talk about back pressure on exhaust, and it's probably the easiest way to understand this, because I get a few people in videos when I've talked about our induction series and I talk about back pressure, and people, oh, so, you know, engines need some back pressure. That's total nonsense, and we've covered this, and guys that have a good understanding of engines will know exactly this. We want less than atmospheric pressure. Not only do we not want back pressure, we want less than atmospheric. We want the collector pulling on that cylinder, and that's what a good exhaust system will do. And again, we're just talking NA for now, but even a good tune length manifold if we get the velocity right, we'll see lower BPs. So our back pressure will actually drop. So something from a log manifold to a equal tuned length manifold. And again, the length will also influence the back pressure. The longer the primary is, the less back pressure we'll have. There's so many things to it, but yeah, good design improves the volumetric efficiency of the NA part of that engine, and that's what we're about. So, but back to the back pressure aspect of the debate, and I helped people understand this really, really quickly, and same with intakes. If velocity isn't important on an intake, don't run a runner. Just bolt a plenum to the cylinder head and see how well it works for you. It won't, because we have stalled air. We have no velocity. So now that boost pressure that we measure on our gauge is measuring restriction, because molecules are just backing on top of each other. They've got to try and push them through and clear that space. Where if we're creating velocity, we're making room for those additional molecules to fill in behind it. And the same thing happens with the exhaust. And I'd say to guys, if the efficiency of your exhaust manifold wasn't a thing, let's just take the exhaust manifold off, we should make more horsepower. And we don't, because that actually creates more back pressure. And people are like, how does it create more back pressure? Because now the air coming out of the cylinder is colliding with still atmospheric air. So the molecules flying out of this port now have to push past all the stationary air that's in the way. So we actually increase the restriction on the engine, and we're not creating any of that negative pressure, any of that funnel effect that we would with a decent exhaust manifold. So this is why you'll lose horsepower if you pull the manifold off the cylinder, because now we're not supporting each other. Even single pipes with no collector will have a better benefit than no manifold at all, because again, the air molecules have to come out and they're going to collide with the molecules in front. Where if we have a pipe and we create velocity and inertia, just that motion, again, the piston is going to change acceleration phases through its TDC, BDC phase. So as the piston and the valve, as it comes up to TDC and pushes that air out, because remember, our fastest point is around that mid-bore, as it starts to slow down, so does the velocity in the exhaust. Well, the velocity that's further down in the pipe will create a negative pressure that keeps pulling on that cylinder. And that's how we evacuate the cylinder and improve the volumetric efficiency of the engine. So yeah, that's not really a debate, but it comes up from time to time. So anyway, back to the cylinder head. So we're going to use very, very basic tools in this one. Again, this is something you should be able to do at home with a die grinder. We're not getting into making windows any bigger. We're leaving the window exactly as it is. We're doing a very basic port job, but will improve the cylinder head dramatically just with simple tools and simple techniques and adjusting for that core shift. So I'll turn the camera around in a minute and show you the actual core shift in this cylinder head. And these are shocking for core shift. 2Js, RBs, anything long, 6-cylinder, generally they're all over the place. And I'll show you what I mean. But why we're able to make more horsepower and torque and more horsepower at the same boost or with less boost. So same horsepower, less boost, or more horsepower, same boost, is because of our velocity targets, that CSA, what we talk about, our airspeed. If we've got a port slightly this way and we've got a port or in this cylinder, they're that way. In that cylinder, they're that way. If we were to CNC them, we just bore them out big. But again, like I talked about, that's something for 8, 9, 10,000 RPM. But for this engine, we want it to work from, say, 3.5 to 7,000 RPM. We're actually going to port it into that core shift. So we're going to use the core shift. So this one might snake slightly that way. This one might snake slightly that way. But the CSA of the port is exactly the same size. So our velocity is going to be exactly the same. And that's going to be the benefit over a CNC. Again, CNC is great for 99% of things, 90%. But if you want something custom, you really can't beat hand port. The problem is cost versus reward. Generally, it's far more time consuming. We can't just lift this into the CNC and obviously press a button. We've got to do it. And the skills that are needed that really do take a little bit of time to generate. Like I've trained a lot of guys, and it can take a while to learn. And again, it comes down to how hands-on you are as a person. Some people are a lot better at it than others because they've worked with tools all their lives. So if you've got half an idea how to die grind, and I'll get guys just on a block of alloy and just try and get a flat line, scribe 40 thou down on a bit of 10 mil plate, and just practice bringing the whole lot down to one. And straight away you'll see all the problems you're going to create. It starts to dip, or if you don't keep the pressure right, you start to ramp up. Or if you go back and forth, it wants to run off the plate. You'll learn a feeling, how to feel it, how to create the right amount of pressure, what direction to go into. These are little techniques that you'll learn before you even get to the cylinder head. A straight line is the hardest thing you'll ever do. So if you can get that right when it comes to doing a round bowl, they're not that hard, especially when you've got a seat as a guide, because the seat is much harder than the cylinder head. So you can use that as a guide. And if you listen, you'll hear the pitch change between the cylinder head and the seat. Ding, ding, it'll start to ring for you, so you know, oops, I'm on the seat again. And again, try and keep it off the seat. What I tend to do is port within about 10 thousandths or half a mil, 20 thousandths of the seat, and come back and finish that. Same as the window. I'll port, because you've generally got like a taper funnel in most windows that compensate for core shift. I don't know whether you can... these aren't too bad. The RBs are really bad for that. So I'll pull it out to within 5 thousandths of the seat, so I can just see a little line that I've got to clean up, and then I'll come back to that and clean that up. So we're going to get this set up, and actually what we might do just quickly is do an inspection on it. We'll get the camera around here. We'll have a look at the core shift. We'll talk about what we're actually going to do in this episode. And in the next episode, we'll actually getting into porting. So this really is just a preliminary series to let you know what we're going to do, and you can follow along in the next episodes. But we're going to go through now and just talk about the core shift, what we're going to do. This still has the guides in it, so we need to be careful. You will clip them a little bit, but try and keep it to a minimal, and just go around, deburr them, make sure you haven't thinned them out too much, because they can tend to crack, especially if they're cast iron. So let's do it. All right, so before we look at the core shift, let's just cover burr basics. What we need to look for in a good burr, and what's a bad burr, or what's an aggressive burr. So we have a few elements to a burr. We have the flank spacing. So that's the distance between each flank, you can see there. So you can see this burr here, if I can keep it focused, is a super, super aggressive burr. And we also have the flank angle. You can see that's quite, as you can imagine, the further we go to parallel, the more aggressive that is going to be. So that's quite an aggressive burr. I would not recommend anyone using these unless you've got a ton of years under your belt. So I've got a few of those. Here's the same sort of thing in an egg. As you can see, really, really wide spacing. These things you can rip out a 3/4 trench, not a problem, right? But they do take some experience. So the problems with this sort of shape, so this is a tree or a flame. The problem is it's got a sharp edge at the bottom. This will actually put lines in your port, especially if you don't get the angle right and you come in like that. This corner is going to dig in. So this is why I prefer an egg. Same as these types of shapes here. That's basically a cylinder with a radius top. I do use them from time to time, but same thing. They have a square edge at the bottom. So if you don't get the angle right, you can create work for yourself. So now we get into burrs like this. So as you can see, that flank distance has closed up. So straight away, this is not going to be as aggressive. And also the angle has been reduced. You're probably, 30 degrees now to the job, where the other ones were way up near 60 degrees. So something like this is a flame. This is going to be much easier to learn. You're not going to hate it as much. There's a little bit of alley in this one. I haven't used this one for a while. But you can really see that it's a lot tighter, and as you use it, because we've laid those angles over, that rake isn't going to be as aggressive when we actually cut the aluminium. So this is another one of my favorites. This one's like an in-between. You can see it's got they are closer, but it's got a more aggressive rake angle on it. So compared to, I'll put them side by side. That might help. So you see the difference there dramatically. So this one's going to take more metal out faster, be a little bit harder on the hands, and want to jump and catch and buzz the port. But the distance is a little bit wider. So this is a more aggressive bit, but nowhere near as aggressive as this girl here. So you can see we're almost probably half the distance in the flank distance there. So from one to the other, you can see we're from there to there. This one's from there to there. That's massive. As I said, unless you've got a lot of experience on your belt, I wouldn't go near these. And these are some of the killer carbide burrs. They're laid over even more. So let's go to, we'll compare these two. You can see the difference straight away. So these are an absolute pleasure. I use these more than anything because I want to take my time. I want to get it right. You can see the angle is probably, 15, 20 degrees, 25 maybe. They're like that, not like that. So they're going to be much gentler when we take metal off. So then it just comes down to the size. So that's the other aspect we need to look at when porting, is the size. If you trench heads or struggle with shaping, it's generally you've got the wrong size burr. So these are two that I use for most heads. These are what we're going to use for the 2J series. We may introduce a finer one. So this is a finishing one. You can see how fine that is. Again, that won't take much off at all. That will just change the RA of the port. So we use this for finishing. But these are our roughing burrs. This will get it pretty rough, but also be fairly gentle on the hands and really, really easy to use. But as you can imagine, as you open the hole up, the closer we can get this to the radius, the easier and more concentric that port's going to end up. And that's why you'll get a lot of people, they'll go and get, a little burr like this, and they'll be using the nose of it to try and flatten something out. But because it has a really, really small radius, all they're going to do is end up trenching the job. Something like this is good for a long wall because we have a longer section on the actual flame of it. So if we're running up and down a wall like this, it'll tend to flatten it out a lot better than something that's got a bigger radius. So something like this, we really don't want to use that to try and flatten a wall out because we have less area touching the job. So it's little things like that you want to think about. But bowls and stuff like that, these are absolutely brilliant. And we also got to look at that radius compared to the bowl radius, and we'll get into that as well as we move along. But yeah, size is very important. I like my eggs or flames. That's pretty much the only shapes I use. I use some small radius stuff around guides. But yeah, these are the main type of burrs you'll see. And then obviously you've got the double cut steel type burrs. You can use them on aluminium. I actually recommend people start with them. Just use plenty of lube and keep them clean, And because they don't take out a ton of material, they're very, very easy to use. They won't chatter in the ports. They won't run off. These are obviously more aggressive, except for this fine one. But the double cuts are, again, they're designed for steel, but I use them on aluminium all the time. So don't let that confuse you. They are, actually, I'll just grab one quickly so we actually know what we're talking about. Yeah, right. One sec. Okay, so here's one right here. So that's a double cut. As you see, really, really fine on the flank, and then they have that extra double cut to break away. But I use that's one I've used on aluminium quite a bit. And if you're just doing casting flash and stuff like that, these can be really, really beneficial. And you don't need to cartridge roll them at the end. You can pretty much just hit them with this. And the texture, the RA finish is actually really, really good. There's not a lot of need to go over it. You can, but, you know, again, so this one obviously is a lot finer, so we can use that. But the double cut, because people are like, oh, no, they're only for steel. No, that's absolutely rubbish. You can use them on aluminium. They just will clog. But, you're not trying to dig into the cylinder head if you're using that type bit. All you're doing is fluttering across it, just trying to take the casting flash down. And when we flutter, we're not going back and forth with the same pressure. What we're actually doing is pressing down slightly, lifting up, pressing down slightly, lifting up, pressing down slightly, lifting up. So when you see that, there's a technique to it. We're actually doing that ever so slightly, but you won't see it. And you can do a little flutter technique where you don't change pressure, and I might show that as well across casting flash. But yeah, look. That isn't a problem. Don't listen to people that tell you you can't use steel burrs on aluminium. You can 100%. I will demo it in the next series, but I think now you've got a basic understanding. Again, if you like really, really good burrs, then Killer Carbides, he custom makes all of them. He has quite a range. That's something I'll start with. If not, you can find stuff like this on eBay for maybe $30, $40. So this, even though this is an aluminium, it has an extra cut just to stop it building up. It's not a bad burr. Something like this, this is one of my Canadian suppliers, I think. Again, that's not really a deer burr. And these last, if you're just keeping on aluminium, they last for years and years and years. I've had this one for 10 years, and like I don't use it all the time, but I use it quite a bit, and I would say this has probably done maybe 20 or 30 cylinder heads, and it's still good. It's probably just starting to get a little tired now. Like again, I've used it so much, but yeah, I prefer the Killer Carbide stuff. But yeah, these steer away from unless you are very, very experienced. All right, let's have a look at the castings. All right, so we're on the intake side. Now we're just going to look at how much core shift this actually has. And you can see from left bowl to right bowl, it's actually quite dramatic. I've tried to line the camera up dead middle of the head, but basically you can see we've got next to nothing on this side. But if we look at this side, we have a massive lump there. So if I can get my straight edge, and we put the straight edge in here. So that's coming out at about 5 degrees off the valve line. And this one is about 15 degrees off the valve center line. It's a bit hard to see with the camera. So quite a bit. So the casting actually is that way. So the port goes like that. So what we're going to do is we're going to blend this, but that wall, if I square that up now, I'll just try and focus in on that, and I'll get that dead square. That's how far, I'll move the camera over. There we go. Let's line it up. There we go. That's how far the core shift is relevant. So that's the port wall to the port seat. Now, if we get the camera over, we'll try and do the other side. If we look at that side, you can see it is bugger all. So we're not going to try and move that wall over to the same as this wall, because remember, we've got another wall on the inside that's also going to have core shift in it. So this wall is that way. That wall is that way. That wall is that way. And this wall is that way. So the port's going to go like that. It's going to S like that. So let me zoom out a little bit. So the port is going to go like that. And we're going to shape it that way. But what we're going to do is we're going to improve all these steps. And we're going to control the CSA right through the port. So this one might go that way. The next one might come this way. But if we can get all these CSAs through the port the same, then the airspeed is going to be the same. So it is slight variations in the shape of the port. Again, over the distance of the port angles might only change by a couple of degrees, 2, 3, 4 degrees. Over that distance, it's not going to affect it much at all, right? So our discharge might change slightly, but the benefit we get from the inertia and the improved volumetric efficiency puts us miles ahead. So that's what we're going to focus on. We're just going to tidy that up, and we're going to measure it, obviously. Same with the wall. We're not going to try and pull that wall right over. We're not going to try and pull that wall right over. We're just going to try and blend it into the casting, an inch or so. Same with the other side. Then we're going to set all the sizing. We'll get into the sizing in the Einstein episode. This one, we're just going to show you how to port it, how to follow the core shift, how to compensate for the core shift and get the best result, the best bang for buck with as minimal porting needed and keeping the volume down in that port for maximum benefit. This will give you earlier boost thresholds, more horsepower per PSI. The engine will come on sooner and it'll be far more efficient. So that's that chamber there. So we're going to have a look at the next chamber to see where it's at. This one actually looks pretty much in the middle, side to side. It's probably a little worse on that, but not as bad as that one. So again, that's fairly easy. This one is actually a little high now. So if I'll lean it over, see how we can see there's more off this section. So what's actually happened with this one is the core's actually been moved back, or it's a little low, and we'll check it on the short turn once we get into the short turn. But that's what's caused this, because remember, all these seat programs from the factory are generally the same. They plunge them all at all the same depths and use the same cutters, but as you can see, it's barely rubbed on the other ports. But in this port, we've got quite a step in that chamber. So I'll try and zoom in a little bit more. So our transition is blending that into the bowl as efficient as we can without putting too much volume in that as well. I don't like a lot of bowl volume in. It's more of a 2-valve thing than a 4-valve thing. The short turns aren't horrible in these, so there really isn't a lot of need to compensate for the, a really, really tight minimal cross-sectional area upstream. We will map these in the other series, but again, we'll just stick to looking at core shift here. So same thing. This one's over this way, so the core is that way in this one. So that's the opposite to the first cylinder. That one's a little high, a little low. And this one again is, let's get the torch on site. This one is a little bit that way. You can see we've got a big lump here, not so much there. So let's have a look at the exhaust now and see what we need to do on the exhaust. All right, so here's the exhaust side, guys. Not too bad. It's pretty much on size, or on center, I should say. The roof is a little low on one side, so we need to fix that up. We've got some sharp edges on the short turn, so obviously we need to tidy them up just there. It's actually, it's even catching the scribe. So as you can see, that there's horsepower to be made everywhere. And again, we're not interested in making this port bigger. We're just interested in efficiency. We want port efficiency. We want the smallest port with the most efficiency. So around the guides, we're going to tidy these up a little bit. Each side, we're not cutting the guides out. We're not cutting the guide lumps out. We're going to leave them again. Efficiency, efficiency, efficiency. Airspeed, airspeed, airspeed. All right. So let's have a look at the next one. Same sort of thing. Not too bad. The exhausts really don't have a lot of core shift at all so far. Not too bad. This one is a little over. So yeah, this is the first one we're seeing. If you have a look at the up in there, you can see we've got a really long section of where they've cut. And if we look at the other side, there's not much at all. So this one is actually across this way a little bit. So we have to fix that one up. Next one. Not too bad at all. Same thing, it's a little on the left, but not too bad. And the last one, yeah, the last one, we've got a bit of core shift in that one. So same thing. You can see in this bowl here, we've got a little bit more machining down that side of the bowl compared to this one over here. All right, so now we're looking at the intake windows. And guys, I am going in quite in depth to look at this head. I don't want to rush through this process. I really want you to understand that analyzing the head, looking at it first, and having an approach is probably the most important part of porting a cylinder head. Doing some measurements, having a look, see what the core shift's like, having a little bit of a plan and understanding that I can't just do the same thing on every single port if we want a super efficient cylinder head. So this is why I'm taking the time. I've watched some port series and just found them really, really rushed. So I'm sorry if this series is a little bit boring, but I am trying to go through the fundamentals and show you every single little point that's going to make you horsepower. Every little detail that is going to make or break the cylinder head as far as port efficiency goes. Now, we're going to looking at the window and you'll see this classic step here. So if we put a straight edge in, basically we're going to pull that roof down to this edge here. So we're going to make that window slightly bigger. It's already very, very small. So we really aren't going to lose anything. But again, I've talked about this before, the injector bosses. I want to keep them as small as possible because this, to me, is considered dead area. I know a lot of people in the industry tend to flow a cylinder head with the injector boss, but when we bolt a manifold to that, that's what we're going to see. This is what the manifold sees. So if we bring that down and keep going, and let's look at the shot. I'll fix the light. Let's kick it up a little bit more. There we go. That's what the manifold sees. You cannot see the injector boss anymore. So don't include it. Don't make it any bigger than it needs to be. Don't make it part of the flow path. Treat it as if it's not part of the port because it isn't. Our velocity stream, our cross-sectional area from the manifold into the port, the transition of this should not include that area. And this is why I block this when I flow cylinder heads. I don't want to know what the injector area flows because when the manifold is on, that is not part of my flow stream. It's not part of my flow path. Again, this is why the manifold angle is important. This roof angle here, that should be our extension. So I don't include that, and I don't tend to make these any longer than they need to be. I finish them off, I just clean them up and leave them alone. So The next one, same sort of thing. But yeah, I don't want to include those injector paths at all. All right, so we've pretty much covered the basics. Now we've got a good understanding. So we're going to obviously use the calipers. We're going to set our window width like so. And you can see it gets bigger in, so we're spreading out to the seat. So we're going to actually map the whole port in the Einstein series. This series, we're just going to get into the fundamentals of porting. But these trenches, I want to leave as small as possible. I'm going to set these to our cleanup once we do one port, and then I can just go along each port and check each window size and use this as a go, stop, go indicator. And we can do the same for our vertical height as well. We just adjust it the other way. We come down like that, and that will pitch in, same sort of thing. So we're going to bring that window down to that little ink casting step because we're going to take that out. So we're going to put a little bit volume in there. It's already on the small side, so we should be fine. You'll probably find once we measure this up, that is going to be the MCA on these heads from memory. But yeah, we'll look at that in the other series. But that's pretty much it for this series, guys. This is really just an introduction. I wanted to go through it fairly in depth so we have a really good idea of what we're actually doing, all right? All right, guys, so this is a little bit of a tedious video and we've really sort of gone right through. It might be a little bit boring, but I wanted to go right into every point so you've got a really good understanding of the tools, the burrs, and everything before you even start. Preparation is the key to anything. So I find that if you take your time, prepare, you're going to have a better go at it. You're going to have a better understanding at what you're actually doing. And the chances of you getting it right are going to be far better. So this is why I've sort of made this as an introduction to porting this cylinder head. In the next series, we'll actually get on the tools. So again, I'm sorry if this has bored you a little bit, but again, we need to understand what we're doing if you want a successful job at the end of the day. So I thought I would take the first episode to really dive into all the tedious parts of a cylinder head. Understanding core shift, understanding burrs, understanding measurements, understanding what we're actually doing as far as injector cutouts and stuff go. Again, I don't like to include them. But yeah, on the next episode, we're going to get into actually pulling some metal out of that and where I like to start. Again, it's up to you. You can either start at the window or start at the bowl. And we're joining those two because we can't change those two factors unless you're doing high ports and stuff like that. And that's a whole nother ball game. But for this one, that's a very, very basic porting series. You should be able to follow along. You don't need a great amount of burrs. Just 2 to 3 burrs will get the whole job done. So probably 3 sizes, 3 types of eggs will pretty much do it for you. But yeah, all right, guys, I'll catch you in the next one. If you like this sort of stuff, give us a thumbs up or a comment. If you don't, say, Jake, that was boring as. All right, and I'll understand. All good. Cheers.